everybody. This is Nidhi from Canopas, and you are listening to the Canopas podcast, the show that wants to make developers' life a little bit easier by providing directive guidance. So, welcome to episode 1. In this episode, we are going to talk about testing, how testing helps our code to be less buggy, what are different types of testing, what are aspects of testing, which developers prefer, and many more things about testing. Today we have Radhika as our guest who has experience of testing on Android platform. So Radhika, can you let the audience know about your development background?
Hello everyone, I'm Radhika. Thanks for having me on the show. It's a pleasure to be a part of Canopas podcast. I started my journey as an Android developer around 4 years ago. Since then, I mostly work on Android and I also have a bit knowledge of Flutter too. Today, I would like to share some tips and tricks to write effective tests.
We all know how important tests are for our projects. Let's start from scratch. So Radhika, why should we write tests?
Basically, we write tests to test the behavior of our code. I can think of a few reasons to write tests. The first one is to find ambiguity. Whether we write test before writing code or both at the same time, it helps us to find error in earlier stage. For example, what if something is null, or what something we forgot to initialize, or something we missed to release. The second reason I can say, unit tests increase productivity as we don't have to spend time manually to checking our code. The third reason, it makes us more confident. We can make changes without worrying if something is broken. The fourth one is unit tests reduce complexity in our code. If our code become larger, it's hard for us to write tests. For example, if our function has a nested if statement, it becomes a difficult task to achieve perfect code coverage. The fifth reason is it also makes debugging easier. Debugging can be a tedious task. It takes time to manually reach the real context. As unit tests break complex structure into smaller parts, it makes it easier to reach the code you want to test.
Thanks for explaining the importance of testing. Now listeners have an idea about why they should write tests. I have heard that there are many types of tests. Can you give us a bit more details on the types of testing?
Well, there are three categories of tests in general that we should add in our project. The first one is unit test. It verifies a unit of application, that usually a class in object-oriented language like Java and Kotlin. It helps us to verify that class is working fine in isolation. The second one is integration test. It helps us to verify that units are working fine together and that class is in our context. For example, if we want to test that screen is working fine, composed of presenter and activity and backend, that will be an integration test. The third one is it test, end-to-end test. It verifies the application from user end. For example, if you have an application that requires authentication, you will write tests that verify the login works fine with the correct credential and user is redirected to home screen when authentication succeeds.
Many times developers complain that writing tests are more difficult than writing code. So do you think it's true to some extent, or any other perspective there?
Yes, to some extent it is true if your architecture is not testable. Few things that I always keep in mind while writing code to make it testable. I make sure that my code is not tightly coupled, it should be reusable. Tight coupling is a primary route to make your code untestable. Code should follow a single responsibility principle. If a particular method consumes information as well as process it by itself, it's always hard to test. One more thing I suggest to take into consideration is that too many dependency also make your code hard to test. So for that, I use dependency injection.
In short, make your module simple, clean and readable. These are the things we need to take into account while doing the coding. What were the difficulties you faced while writing tests in real applications?
Well, I faced many difficulties while writing tests in real app. Some of them I would like to share with you. The first one is bad architecture. Our architecture should have a separate UI from business logic. The second one is too many dependency, which make your architecture non-testable. We should have a minimum dependency whenever possible. The third one is tight coupling, which make architecture hard to test. Complex function and method also make your module untestable. Function and method should be smaller and simpler.
Many times we are pulling out our hair into badly designed code because we literally have no idea about what's going on. So Radhika, how will you approach writing tests into applications where architecture is not designed for test?
The clear-cut answer to this question is that I will first do refactoring to make code testable. I can say that without test you are working with the fire. First thing I will perform to make code testable by refactoring the architecture with MVVM or MVP. Secondly, implementing dependency injection, which improves your code testability. The third one is whenever we start working on a new feature of some non-testable architecture, make sure that module in which you are going to add a new feature is well structured and testable. If it is not, then do refactoring with writing or correcting unit test before starting implementation of new features.
That was really useful. Most of the time we are writing tests in existing projects which do not have a good test coverage or no coverage at all. So the tips you have provided should be very helpful. While we are on coverage, do you measure testing coverage? I have heard people saying it's not so useful metric. Do you have any opinion on it?
Android has an inbuilt feature that runs tests with a coverage matrix. Jacoco is a great plugin to check the test coverage. We can also integrate it with Git CI/CD, SonarQube, or GitHub Action to automate the code coverage verification. The answer to your second question, I can say that coverage matrix is useful only when we write tests to check the behavior of code, not the line of code. If we have 100% code coverage, that doesn't mean our written code is good enough and with no bug. I can say that code coverage is a powerful tool to improve quality of the code as long as we do not blindly optimize for maximum coverage.
Thanks for clarification on coverage. So it seems test quality matters more than test quantity. Do you have any tips on how to write good tests?
Yes, I would like to share a few best practices to write effective tests. First one, our tests should be fast. If they are slow, developers will not run them often as they should. To make your test fast, make them as small as possible. Don't make them dependent on other tests. Mock external dependency wherever required. Second one is that tests should not duplicate implementation logic. The tests should be readable. If tests are hard to read, developers are more likely to misunderstand them and introduce bugs. The last one is test-driven development practice, which we should use in our day-to-day coding.
That means whatever we create, test first, then code. But consistency is a key here. I have seen projects where some developers contribute code with good test and coverage, but not everyone. Do you enforce any testing on the projects? If yes, how do you do it?
As I said earlier, by introducing TDD practice in day-to-day coding help us to write fully tested code. Automated testing and code coverage verification is a great way to enforce testing. As I mentioned before, implementation of CI/CD that runs test on every commit and measure coverage with Jacoco will be the best way to get started. We run test pipeline on pull request to ensure that our changes will not break anything before merging it into master. This makes sure that the master is always green.
That was a really straightforward explanation. Let's hope all developers will contribute code with good test coverage so that we would not need to force it. However, it's good to have enforcement on CI to make sure anyone does not break it by mistake. Coming back to the testing, most of the platforms have different frameworks and libraries available to facilitate the testing. What is the state of testing in Android and how does one start writing it?
Well, there are many testing frameworks available in Android to test your code effectively. The basic one is JUnit. It is a default testing framework of Android. All other frameworks such as Mockito, Robolatrix, and Espresso are built on top of it. Espresso is a test automation framework to test user interface, and it's provided by Android team. It allows us to interact with UI elements of the app such as edit text field and button, which verify app's behavior in correct manner. Robolatrix is a unit testing framework that runs on a JVM. This improves the execution time of test and allow us to set up a test to be run on a machine where there is no connected hardware or emulator, such as a continuous integration server. Mockito is an open source mocking framework for unit testing, which allow us to generate and configure a mock object for Java interface or classes. Mockito helps us to test an app that has a dependency by effectively mocking it.
Thanks for listening to the Canopas podcast. Make sure to check the show notes to discover our informative materials related to this podcast. If you have any questions or you are interested in further discussions, please feel free to reach out on our Twitter handle @Canopas Software.